Okay, looks like we're live. Hello, hello, hello. Hope you're having a fantastic day. Today we're going to be implementing surface nets. I thought we'd take a break from ray marching for a little while because this is something that needs to be done as well. Surface nets is a mesh generation algorithm similar to marching cubes or dual contouring that basically takes voxel data and turns it into sort of smoothish terrain. You can make it much smoother than this. So you can see some examples here. Smooth voxel mapping, technical deep dive on real-time surface nets and texturing. So, pretty interesting idea. I'm going to follow, I think, the first one, although this is also looking like a pretty good tutorial here. So first we'll start with generating the samples, which actually we already have. So if I go to the main function here, we've got this scalar field, and here we're filling it with 255. Yeah, okay, I need to open a new window here. New tab, rather. So we'll just build. Okay, good. Right, so now we're drawing cubes at the moment, and we've got a, which one is it? It's cube vertex shader. That's pretty simple. So we're actually just constructing a cube at a position, and here's the shader. We're just drawing a white color here. Now, obviously this is not going to be what we're going to use. We're going to actually draw a mesh instead. So let's have a look. The first step is the signed surface function. So that's basically what we've already done in the terrain generation, which is to create a bunch of sample points which are either inside or outside of the mesh. In their case, they're using purple as being outside and blue as being inside the mesh. So in our case, it would be, I suppose, 0 is outside and 255 is inside. Now, this is a tutorial by Ryan Dremmer, by the way. It's on Medium. It's one of the first search results that comes up. It's for Godot, but I think we can probably adapt it to our situation pretty easily. For every sample point, we check 3 neighboring sample points, the nearest point in each positive axis direction. And if any of those 3 neighboring sample points are a different sign, then we create a quad to separate the current sample point from its neighbor. Right. So in this case here, you can see there's 3 inside, 1 outside, and then they create a quad. That makes sense. Most platforms have a directional quad. These platforms will need to create reverse quads. Okay, that's fine. Okay, so I suppose we can try this step. We already have these cubes being rendered, so let's just unrender them. Actually, maybe I can use the... I used to have that pipeline that could draw points. It's like the point pipeline or something. That's okay. So what we need is a pipeline that can just draw arbitrary vertices. Okay. That shouldn't be a problem. We've got a composite pipeline, SDF, cube, debug. Yeah. Okay, so we're going to need arbitrary vertices. Let's think about this. How many faces could we possibly have, or how many triangles? I guess it's better to just overestimate right now, and then I'll figure it out later. So we're going to have to allocate memory for a new buffer to store all this mesh data in. So this is going to be the surface nets pipeline, the render pipeline, surface nets graphics pipeline, because there's probably going to be a compute version. I think I might do it on the CPU first and then change it to a compute shader later. So we want surface nets graphics pipeline. Actually, you know what? I can probably just copy this. The composite pipeline. It's got some descriptors. It's got a few things. We'll just copy that. Put here. There we go. And we'll change it from composite to surface nets. So we're going to need an image sampler. I suppose not. No, we're not going to need an image sampler. We're going to need none of these. Yeah, we don't need any of that stuff. No descriptors. No sampler. Okay. So this will be surface, that's vertex shader and fragment shader. Sure. It's going to be a list of triangles, yes. It's going to be filled. We're not going to cull anything right now. Or maybe I should do cull back. Just get that working off the bat. This viewport is flipped. We don't want that. Okay, we don't have descriptors, so just get rid of that. Okay, all good, I think. We just need to make a bunch of variables up in the context. Surface nets. Okay, what are we missing? Okay, these shaders don't exist yet. That's fine. Shaders. Surface nets. By the way, I can really see the benefit of compiling shaders before running the program now that I've been using SPV for a while. Because you can look at the assembly, whereas when I used to make stuff with OpenGL, you'd always compile it at runtime at the beginning, well I would, and then I would never see the assembled code, so I could never make any real, I could never use real information about what's happening. I would always have to guess, which is actually pretty stupid now that I think about it. Okay, so we got a vertex shader. We're going to have some location 0. There's going to be inputs. We're going to have position. And what's the other thing? Oh, we've got to put a type here. Vec3 position and a vec3 normal and vec2 UV. And maybe color. That's pretty big vertices. I guess for now we can just have position. We probably just need a position right now. We'll use that other stuff later. Okay, great. So we're going to say out is... Oh no, we don't have to do this. I think it's automatically vertex position, right? GL underscore position equals like that kind of thing. And we need, actually we do need a uniform matrix, but we can use push constants. That's fine. I really like these. They're quite nice. So we're going to have an MVP matrix. Not uniform, map 4. Yeah, we'll just pre-calculate it on the client side, pass it in. And actually we don't need M, because I'm going to use world position. It's not an instanced, so just view projection. So it's going to be VP times in position. Yeah, I think we have to change this to a vec4 and set the W component to 1 to get the projection to work, right? Okay, surface nets, vertex shader is, I think, done for now. We'll try fragment shader. Okay, we're going to do, what did we get in? Nothing. We're not sending anything over, so I suppose we can just return, although I think we have to specify this, we don't return it. Layout, yeah, location equals 0, out, and let's set that 4. We'll just make it a sort of reddish color here. Okay, so that should be able to draw simple vertices. And we got to build this stuff. So I'm actually going to get rid of all of this. I don't get rid of it. I'm going to just comment it out because we're not going to use any of it. And I'll actually just copy the cube one. Why not? Okay, replace cube with surface nets. There we go. So I'm only going to compile surface nets right now. We don't need to keep recompiling all the shaders. Apparently, I messed up. Did I call one of them the wrong name? Surface nets. No, oh, it didn't compile. Let's see. Push constant. Oh, right. Of course. I forgot the uniform part. Okay, great. This should resolve itself. There we go. We've got a pipeline done. That was really easy for once. That's good because we've got to get onto the hard stuff. Well, the slightly more challenging stuff. Hopefully not too hard. So, main render pass. Composite images. Okay. Do we need to do all this stuff right now? Let's see. No. I'm gonna put a big comment around. This should probably go here. This stuff. There we go. We should have only cubes now. There's something wrong. What is it? Push constants are used, but I didn't. I didn't define it. Okay, I think it's in the surface nets. It's gonna be in, where is it? Usually. not render targets, not scissors. Maybe it's just, yeah, push constants. There we go. So this is usually an array. We want something in the vertex shader. Size is going to be just a map 4, I guess. And offset is 0, so I'll just leave that. Okay, that's all good, I think. Oh, no, it's not. What is this? Attribute description does not have location 0. Ah. Yes, I didn't define attributes. I don't think I'm even using attributes at all in the current pipeline, so I didn't have that to copy. Yeah, I guess usually I would put that here. Vertex input, I think it is. Binding descriptions. Vertex input binding description. Okay. Binding 0. Stride is size of. I think right now it's, what was it? Just a vec3. This is going to come back to bite me, I think. Input rate is vertex. Is that the right format, or is it like this? What's wrong with this? Oh, I need to put the type here because it's a maybe. Vertex input config. There we go. Happy about that? Okay, and then the next thing is the attribute descriptions. There we go. Location 0. Hang on. Binding 0. Format. Oh yeah, this is interesting. I'm having a brain fart here. What the hell? Yeah. R32, G32, B32 float. That's what I want. I guess S float. Yeah, signed float. Okay. And offset is 0. Okay, that's fine. Okay, good. Alright, now we're still drawing the cubes, which is fine. Actually, I might change the cube shader a bit here. I don't have blending enabled. What the? If the voxel coordinate is greater than or equal to 16, then do this, otherwise do this. Right. Oh, okay. Interesting. So we're using the SDF bit field, we're not using the texture in this version. That's fine, I guess. So I'm just gonna do this. There we go. It's not gonna work though. Because we need to enable blending. Also, I totally broke the code because I had to delete the index stuff. I think we can just use, actually we can just use the second one. Yeah, okay. Good. Okay, cube stuff. There's cube stuff. Cube pipeline. Where is it? Oh, it's up here somewhere. There we go. So I want blending, blend enabled, true. Okay, there we go. That's easy enough. Okay, cool. I just wanted to make them a little bit less intense, but that's still really intense. So let's turn the opacity down. Okay, great. Good, good, good. All right, now. We've made our surface nets pipeline. We've made a buffer, I assume. Actually, I don't know. Let's have a look. Does this allocate a buffer? It's been a while since I used one. Creates a shader module, creates a pipeline layout. Doesn't create a buffer. Guess that makes sense because we don't know how big the buffer's got to be. So that means I need to make it myself. Luckily, there's a function for that, which I didn't forget about this time. So we're going to create a buffer. It's going to be a vertex buffer. The size is going to be, I suppose we'll call it surface nets vertex buffer size. Memory properties is going to be, I'll make it host visible and host coherent because we need to upload data to it. Sharing mode, exclusive, and we get back a buffer and some memory. Okay. Bah. So we're going to get the buffer and the memory. There we go. Now we just need to make these three things. There we go. Buffer size, buffer and memory. Just change this. Surface, nets, vertex. There we go. Is that wrong? Surface nets, vertex, buffer size. What's the problem? No, made a typo. Always. Okay, good. We need to actually set the size though, otherwise it'll be 0. So we're going to take this. And I'm going to set it to size of vec3 multiplied by, let's do, I guess, 1 quad per voxel. I don't think that, I think that might be too much, but anyway, we'll do that anyway. Just make a little bit more space than we need, hopefully. I guess the ideal thing would be to make the buffer after you calculate the surface nets, which would mean, you know, making a temporary large buffer maybe, putting all this data in there, calculating how big it is, making a smaller buffer afterwards, etc. Anyway, let's see. So make the cube densities here. No, I just realized I don't have access. Oh no, I don't need access in the shader. I'm going to use the CPU. Alright, so we got the scalar field. Here it is. And generate surface nets geometry. Okay, so we're going to go over this scalar field, which is accessible here, right? Yep. It's just a scalar field of bytes, and there's 0 and 255 at the moment, which I guess we can just leave. So let's have a look at the article here. Okay, so this is just outlining the steps. Okay. Right. Okay, so I guess actually we'll go through this step by step. So for every sample point, check the 3 neighboring sample points. Okay, so for every sample point, that means we've got to go over every value in the scalar field. However, we probably want to go over X, Y, and Z. And do I have a thing here? I do. Index from coords int. Gonna give us, yeah. That's good, yeah. Multiplied by 16, multiplied by 256, right? Alright, that's good. We can get the index easily. Index from coords. Pass in X, Y, Z. I should have actually just seen that right there. It's up there. Oh, I can't go to it apparently. Oh, I just realized the text is really small. Damn. I'm gonna see if I can make this a little bit nicer. Yeah, that looks good. Maybe I should change my tab size if I'm gonna have text this large. Where is it? It's not here. It's in app data, roaming, helix, languages. There we go. Odin, make the tab width. I don't know if I can handle 2. Maybe I can. Yeah, I guess that's fine. Reminds me of the JavaScript days, but more fits on the screen. That's really the most important thing. I bet you someone is going to come in the chat and be like, 2 spaces? Because it's the most important thing in programming. Alright, so we're going to get the index and we're going to compare it to its neighbors. So let's see. I suppose we can just get the value. Scalar field. Okay, I'm going to compare it only to its 3 neighbors of on the positive directions. That's the rule. I don't really understand why. In each positive axis direction. Okay. So, I guess we'll call them X, Y, and Z. No, we can't do that. N, X, N, Y, and N, Z, but that's usually normal. Whatever. Scalar field. But the problem here, which is always the problem with these types of algorithms, is on the edges you can't go one more to the edge. I mean, you can't go one more because you don't have the data. So what do? You could generate it using this, So you could actually just generate the outside, which maybe I'll do. Yeah, I think I will actually. So I'm going to say, this is just going to be in an if condition here. Why did that not copy? If on positive direction edge, generate neighbor. So there's a couple ways you could do this usually. You could just generate the other chunk and then sample that chunk, or you could just generate the value again, and it depends which one's going to be more expensive and a lot of stuff. It might not be worth it to generate it twice because maybe your terrain generation algorithm does a lot of other things besides just using some noise, which is what mine's doing. This will do for now. I can't believe I spelled neighbor without a U. Too much programming. I always use American spelling when I'm programming. So this is going to be x plus 1. And we'll just copy this. No, I shouldn't have copied it actually. Y, Z. Okay, very straightforward. However, if, I don't need the parentheses, if the x position is 15, then we have to do the other thing. Otherwise, we do this. The other thing is this. What is this gonna be? Oh, I can't just do that. I have to basically say if it's above 0.5, it's 255. Okay, so the other way around. If it's above 0.5, it's 255, otherwise 0. So this is actually going to be a byte. There we go. Yeah, alright. Same kind of thing here. And of course, this value needs to be changed as well. There we go, plus 1, there we go. And finally, NZ. Let's delete this, add a 1 here. I think we should be good to go. Okay, so we got our NX, our NY, and our NZ. Now, what do? We check if any of them are a different sign. We create a quad to separate the current sample point from its neighbor. Okay, so then we would say if, well, hang on a second. A different sign in our case is going to be 255 and 0. I think we're going to have to change this later. Because if we want smoother terrain, the value of that might matter. Although it seems like it uses a recursive smoothing function, which is different to what I would have expected. Yeah. No, but it does linearly interpolate between the two samples. But that's just their positions, right? No, it's the value. Okay. Yeah, so we might be in a bit of a problem using these U8s now that I'm looking at this. Maybe we should just use the noise directly. We can call it a sample field. And then here we just say sample field, grab this. equals n. Okay, now down here we can use that instead of this. Just gonna make all of this a bit different. Probably don't need to call it a sample field. It is still a scalar field. Or a sign distance field even. Yeah, let's just go up there. And grab these and delete those. There we go. Uh-huh. Yeah. That's fine. I'll make these floats. Okay, good. No, float is not the right keyword in this language. F32. Okay, that's good. Now, what do we got? Okay, so we need to generate a quad now. Based on the signs of the sides. So, I guess we'll just say if, what's the easiest way to do this? X is, what, we don't have the X. We don't need the V. If V is greater than 0 and, wait a second, that's not the best way to do this. How would you easily check if both things are signed or unsigned? Okay, I'll do it the stupid way first. And nx is less than 0 or, and this actually needs to be together like this. V is less than 0 and nx is greater than 0. Okay, so that makes sense. Then we would make a quad here. So we need to create quad along x-axis. Okay. Let's think about that. I gotta open something to draw in. Let me just move this here. Let's close all this other stuff. Okay. So we've got points. Let's just say this is the x-axis. So we're going to move along the x-axis to the middle, between the middle point of these two. Then we're going to go, well, we're doing clockwise, right? So I guess this way. And then this way. That should work, I think. So that's not too hard. That should just be plus 0.5 and 0.5. Yeah. Okay. So we're going to say position for vertex 1. P1 is going to be, do we actually have an X position? Or no, we're just using the loop here as sort of a guide. So it's going to be vec3 f32 x y z. P1 is going to be P plus X. Oh, sorry, no, it's going to be P plus 0.5 on the x-axis, and then y is going down. It's going to be, we're going to do this one first. So it's going to be negative 0.5 on the y-axis, and then z is going this way, right? I'm sure I drew a diagram somewhere. That's wrong. Okay, I need to draw one, so I don't have to look this up again. But there should be a Vulkan projection matrix that I've looked at. Is it this website? No, I don't think it is. Vulkan axis directions. Okay, y plus is down, yz is out of the screen. Yeah, okay. Alright, so y plus is down, and z is out of the screen. Okay, that's good. So this is incorrect. Okay, good. Now, if we're creating this, it is plus on the x, minus on the other two axes. Okay, easy. Okay, and now P2 is going to be P plus on the Z, and then P2 we're going to do this one because we're going clockwise. It's going to be plus on the Y, minus on the Z, and then P3 is going to be plus on the Y and plus on the Z. Then P4 is going to be plus on the X, minus on the Y, plus on the Z. There we go. That will give us our quad corners. And I suppose I can just append these to an array or something. So we'll say vertices, surface, nets, vertices. At the moment that is vec3s, so that'll be fine. And we'll just make this a dynamic array. And on the temp allocator, although it doesn't really matter, we're not clearing any memory right now. And this is only going to happen once. And so then we append surface nets vertices. So we do P1, P2, P3. Actually, this needs to be vec3 slice. I think we can do that, yeah. And then we append, what is it? P1, P3, P4, yeah. That should be correct, I believe. There's a problem, floats don't exist. Yeah, okay, fair enough. Okay, so hopefully we should have created one quad along the x-axis if this is true. So what we're going to do is we're just going to run this now. I'm going to test. And actually I'm going to put this outside of here just for now so that I can see the values of it when this goes out of scope, because if I try to do a breakpoint here, it's going to be out of scope usually. Is this the right? No, this is the wrong files. So we'll just do an F10, step through here. No, that's not what I wanted. There we go. Line 1700. It's probably a shortcut to go to a particular line. We'll just put something here and we will break, and then we'll look at surface, nets, vertices. Okay, apparently doesn't exist. What the hell? Now, did I make it one word? No? Okay. We did go, that's out of scope, okay. We went even further. No? That should be in scope. Maybe I didn't build. Yeah, I think I forgot to build. There's nothing in there, okay. Well, let's step through this then. Have a little look. Alright, so we got our V value here. Let's just look at locals. No, there's too many locals. Let's look at V 0.5. Let's look at sample field dot data, and it's an array of 4096. Okay, so 0.5, and there's a few below 0.5. Okay, so this is, yeah, because we normalized it to 0 and 1, but we should have left it in this case. So I'm actually gonna, why did I do that? I can't remember. I'm just gonna get rid of this normalization here, because we can get exactly the same effect with this code. And now we have properly negative and positive values. So actually, if I skip to the next breakpoint and look up, why did I delete it? What's it called? Surface nets vertices. There we go. Alright, we got a bunch in here. We got 1,470 apparently. That's a lot. And we'll make it surface nets vertices dot length. There we go. Actually, this should be dot data. Alright, there we go. Alright, so you can see we've got, yeah, that looks correct. They're lining up on the correct axes. Okay. That's a good sign. So what I'm going to do now is I'm going to try to render it before I finish this. So what we need to do is basically something like this, except it's more annoying. We've got to like copy to a temporary buffer or something, I think. Oh no, we don't have to do that. I think we should do that, but we don't have to, because we made the vertex buffer CPU side visible. Is there a problem with that? Vulkan, no, you know what? I'll check it out later. Alright, so we want to do data, and it's just a bunch of vec3s. We want to map the memory, and we want to unmap the memory. And then we want to wait until that's done. This is the really quick and dirty way. I actually haven't verified that it works, but I think it does, because it says it waits for any fences that could have been created from previous functions. So this is not going to be the storage buffer. This is going to be surface nets vertex buffer. I need to get some water. All right. Sometimes there's very loud sounds in my apartment. It's weird. Alright, so vertex buffer. And I guess we're just gonna iterate over for vertex in surface nets vertices. No, we don't need to do that. We just memcopy. Memcopy data. Surface nets vertices. Times size of okay. Well, that should work, I think. Can we test that? I think we need to draw with it. So let's go down here. So we'll just grab this, which is going to be pretty much the same. Okay, and this is going to be, instead of debug, surface nets. Nope. Push constants. We can still use the same one, I think, the same memory location, because it has the projection view matrix in there, that's fine. But we'll just say that it's a single matrix. Surface nets descriptor set. I don't think we have one of those. And we're going to draw, I guess this is not something that I have access to, so I guess I need to set that. The length of this dynamic array here. So we could do surface nets vertex buffer, no, vertex count equals just the length of this. I don't know if we need to actually keep the vertices around. This can just be an int, I guess. What's wrong with this? Surface nets vertex. Oh, not buffer. Okay, the instances, I guess we'll just do one. So we're going to draw all these individual vertices using this pipeline. Okay, which does have culling right now. It's a triangle list, that's correct. Alright, let's just see what happens, eh? A crash. Oh, I didn't begin rendering, I guess. Or rather, I should just put this down here. There we go. Okay, that's still not okay. Right. So, let's see, from the top. The depth attachment, if the current render pass instance was begun with begin rendering, The feature is not enabled. Image view is not null. Depth attachment format must be equal to the format used to create the depth attachment format image view. So I need a... Okay, let's fix this one first. Most likely you forgot to call bind command buffers. I did forget to bind a vertex buffer rather. Okay. So bind vertex buffers. First binding is 0, binding count is 1, and the buffer is surface nets vertex buffer. And the size there we go. Now the thing about the depth test, I guess I could I just turn it off here? Oops, that's not false. Let's see. So, the offset, did I set the offset larger than the buffer size? Whoops. Okay. Fix that first. Is that this last one here? Offsets, yeah, whoops, why did I do that? So this should just be nil. Okay, finally, offsets is null, you can't do that. What? I thought you could. Oh, I think I remember what I did before. It was this. Device size, and yeah, you could probably just do this device size, and that would work, I think. Cross binding, binding count, buffers, offsets, yeah. Okay, next thing. Alright, so image view format, depth 32 float must match. Okay. Dynamic rendering on user attachments is not enabled, so I need to either turn on depth for this pipeline. I'll probably just do that. Is it? I thought it would have already been turned on. Oh, I called end rendering twice. That's not good. Oh, hey. Would you look at that? Yeah, interesting. So, is it wrong? Yes, I think it's wrong. But we are drawing quads, which is cool. Oh, I should have looked at the errors. Okay, there's going to be a bunch of them. What are they? Okay, so it's about the depth buffer, and the dynamic rendering unused attachments feature is not enabled in the pipeline. Okay. Let's have a look at Surface Nets pipeline layout. Here it is. There's nothing dynamic in here, so I'm actually going to put in dynamic state. And I'm going to enable... Hello, what's the problem? Oh, it's an array of dynamic state. Yeah, can I just... Depth? You're not going to work for me? Depth test enable, yeah. Is that gonna work now? No, it's still not happy about that, huh? What's the problem? Dynamic rendering on these attachments. The depth attachment image view format must match corresponding format, which is undefined. Why is it undefined? Oh. I think I've got to specify it in... Where is it? Here? Yeah. Depth format. DS32 float. Alright, there we go. Okay, there we go. That's better. This is wrong, but kind of interesting anyway. So it looks... Yeah, it's weird. It looks kind of correct. See, they're all kind of lining up to the edges of voxels here. It's just not exactly... It's not doing it on the edges over here for some reason. And on the left edges, it looks like it's doing it facing the wrong way. I don't know why I said left edges, but you can see these partially invisible voxels here. They are pointing, the face is pointing this way, right? Oh, you can't see that. I just realized. Alright, when I turn on my drawing thing on the screen, it doesn't get captured, it just freezes my stream. Well, that's not great. Anyway, you can see they're kind of facing that way, but the faces drawn are still facing the incorrect direction. So let's have a look at the code. Now, could that be because, well, because of this? If the value is greater than 0 and the neighbor value is less than 0, or if the value is less than 0 and the neighbor value is greater than 0. So that's going to do both sides, right? Which... Oh yeah. Okay, let's have a look at step 6. Grading quads. Now that we have some IDs assigned to each of the sample points and surface points, well, I don't have that actually. So I guess I skipped something. So this was just an explanation. I wasn't actually supposed to do it according to this tutorial here. To create a surface quad, we need to know the locations of each of the 4 vertices. I'm going to call surface points. Oh, so I already did this part. Right. Okay, cool. The easiest way is to place it in the center of a sample voxel. A voxel made of the surrounding 8 sample points. Right, yeah, I decided not to do it that way. But that's okay. Well, anyway, let's, I guess basically grab this. I feel like there's easily a way to replicate this for the other axes in a loop, but I'm just going to do it brute force here. So we're going to say nx is going to be ny, and p, yeah, so this, I guess we just swap these. I don't know if that's correct. I should probably individually verify each axis, but I'm going to try this first and see what happens. Okay, this is the y-axis. I don't really need to put this comment here because you can tell from the parameters of the conditional check. Okay, and now for NZ, we'll just do exactly the same thing here. Okay. This is probably not going to just work, but I'm going to try it anyway. Alright. Okay, so those are definitely backwards. These are the correct direction. So the X edges are actually working, except for some reason it doesn't work on this huge face here, which I thought it would, because we're not skipping the edges, we're just saying... actually, you know what? We're only sampling the positive direction, that makes sense. Okay, so I actually have these little debug shapes here to tell me which way is positive. So positive X is actually this way, which means these are all kind of wrong, because they shouldn't exist. And then these ones are backwards. So, did I just get my clockwise thing totally wrong? I thought it was correct. X is this way. The clockwise is like that. Alright, I will just reverse them then, and we'll see if that works. So, I'll just do the x-axis first. So it'll be P3, P2, P1, P4, P3, P1. I think. So 3, 2, 1. No, 3, 2, 1. And then 4, 2, 1. Yeah. That was actually wrong in what I did. But anyway. Wow. Whoa. Okay. Well, we did get these ones working. I didn't see that wall there before, but maybe I was just looking from the wrong direction. So these ones on the x-axis are now working correctly. Kind of what I would have expected, except these ones on the edge don't work. Or, actually maybe they do work, and the next chunk is solid here, which would make sense. These air tiles, though. Totally not what I wanted. Okay, so let's try reversing the other ones. All right. Almost. And obviously if I turned off culling it would work, right? But that's not really a good solution, because then you're drawing double the amount of stuff. Okay, let's go from the beginning. I'm going to delete the other two axes. We're going to do just the x-axis. The x-axis is facing that way. So, this, I mean, this is a surface, but this surface is facing into the shape, which is not what I want. However, the ones up here, which are facing the air, that's correct. I don't think this algorithm is... Maybe I'm just doing it wrong. I'm probably doing it incorrectly. Let's see. Let's see, thinking about quads. Yeah. If any of the three neighboring sample points are a different sign, then we'll create a quad to separate the current sample point from its neighbor. So you can see here, different sign. Yeah, that makes sense. the sample point has one neighbor of a different sign, we draw one quad. Yes, indeed. Okay. So we sample the field in the positive x direction, right, to get the neighbor. Why is it only the positive direction? Let's think about that. So if we have, I'll just do it in 2D. So let's say this is the positive direction, and I guess we'll do down. Down is the positive direction. Okay, so we're going to sample this one and this one. So we're sampling this guy. Okay, that's great. Now we're here, and we're going to sample this. Okay, I guess that makes sense. And now if we're here, we're going to sample this. So I guess it would prevent you from double sampling because these ones would only need to sample here. But that means you'd never get these edges, which is probably fine. And there is a bad bot problem on Twitch. Okay, that makes sense. Now, yeah, I think that's reasonable. Okay, so sampling in the positive direction. Okay. Oh, I'm silly. I've still got the normalization here. How did I not see that? That's probably only going to be affecting the edges. But that does make a big difference now, hey? Okay. So these ones, though... What the hell? I think I need to actually say the sample itself needs to be... The sample itself needs to be negative. What did I set them as? Greater than 0 is... Okay, so greater than 0 is solid. So in our case, we need to be greater than 0, and x needs to be less than 0. So we're going to get rid of that second check. Alright, and that's just going to give us positive x direction. Good. Fantastic. Now, we do the same thing for the other two axes. Let's have a look. Okay, that is incorrect. They are on the correct spot. They are winding in a way that makes them invisible. Yeah, probably because I didn't actually take care to make sure this is correct. So I'm just sort of converting it straight up. So let's just do this again. So if we have a look at our first one here, it's these values, which I will just copy to here. So this is our x-axis. P plus 0.5. So let's say the second point is here, plus 0.5. Okay, and then minus 0.5 is up here, and then minus 0.5 is actually this way. So that's P1. Then P2 is plus 0.5, plus 0.5, and then minus 0.5, which is this way. That's wrong. That's probably why we're getting weird results, right? Wait, plus 0.5, plus 0.5. Oh no, sorry, I'm stupid. This is minus, yeah, which is, it is that way. Okay, it was not incorrect. P2 and then P3 plus 0.5, plus 0.5, plus 0.5, and plus 0.5 minus 0.5 plus 0.5. So yeah, that's what I expected, but for some reason it's weird. The winding order seems to be backwards to what I expected. So I would have expected 1, 2, 3. Because if we look at the pipeline, where is it? Okay, thank you, most likely bot person. I appreciate that. Yeah, let's stay connected. Sure, send me a DM. So the front face is clockwise. 1, 2, 3. That's clockwise. 1, 2, 1, 2, 3. 1, 2, 3. That's clockwise, right? Clocks go this way. So why is it backwards? You know? Don't make no sense. Oh well. I will reverse these. And that should fix the y-axis. Oh, it's still open. It did not. Oh, maybe it did. I gotta go up here. Nope. Oh, the y-axis is just busted now. What? Oh yeah, because I made them all the same point. Okay, so let's have a look at that. Actually, you know what? It's fine. I ain't got time for this right now. Which are usually the kind of things that come back to bite you, huh? Damn it. That was the most inefficient editing, but anyway, whatever. Okay, let's just see. Okay, positive y is down though. Wait, no it's not. Oh, yo, did I flip my... Oh, did I flip my world or something? Y is going up. Okay. Alright, so my Y direction is actually up, which maybe explains the issues that I was having with the ordering. Whoops. Did I... Oh, I think I changed it because I wanted elevation to be easier to understand, but... Okay. I'm stupid. Okay, so that means basically if we flip these, we should get the right result in this order, I think. Yeah. Okay. Well, whoopsie daisy. Now, what's up with this? The Z-axis is totally... No, I just kind of rotated it, I guess. Okay. That's not correct. This should be based on the x-axis, not the y-axis. Is that right? No. I think I want to do this. Okay. Z-axis looking good on the positive direction. X-axis looking good. And Y-axis is looking good. That's great. However, there are still missing quads on the negative directions, which is a problem. So I feel like this is not complete. Even though I looked at it here in 2D and it seemed to make sense. Let's see, we got like I should actually just ban this bot, hey. Oops. Okay, there we go. I haven't had many people in the chat the last couple of days. This was only so much ray marching debugging people want to watch, huh? Let's see. That's all right. So let's say these are negative, these are positive. Something like this. And we're going in this direction. I guess we'll go up and right. So from here, these, sample this, nothing changes, sample this, nothing changes. This is negative, so we're going to sample this and put a box. This one's going to sample this. See, but this one is going to sample here, and we need to reverse the face. Okay, that's the problem, right? Yeah. Okay. I see how I could do this, I think. So if we say, I'll just do it on the y-axis first. V is less than 0 and ny is greater than 0, and then I'm just going to grab this. So my idea here is we just need to reverse the direction. Here we go, and then we do 1 and 4. Because we still want to check, yeah, or we could just check negative directions from the, oh hey Christopher, thanks for letting me know that you're there. It's all good. I've just committed to 6 months of this to see how it goes. And we'll see what happens. But yeah, it's fun regardless. I get to work on something pretty interesting. And people do watch it on the YouTube VOD, so that's good. Okay, so we got reversed vertices. So yeah, this is kind of the same thing as just checking the negative direction if we're inside, which we could also do, I think. But anyway, let's see. That did not work. If we go above, okay, we just broke it. If v is less than 0 and ny is greater than 0. Oh yeah, right. This has to be an or. And these have to be in parentheses. There we go. Alright. Okay, that's looking much better. Much more solid. Fantastic. Okay. I guess we can just use the same thing. For the other two, yeah. We're probably going to remake this in a compute shader anyway. So it's not a big deal. So for this we'll reverse the order. Nah, it was supposed to be the other one, wasn't it? Yeah, we reverse the order of this one instead. 3, 1, 1, 4. Okay. P1, 2, 3, 1, 3, 4. Alright. We're good. We're almost there. Sometimes when I'm editing code like this, it's sort of like overloading my pattern recognition and I just start editing the wrong lines and stuff. Like, okay, that's wrong. But, okay, so x-axis is not working correctly. Y-axis, z-axis also not working correctly. Alright, fantastic. So, well, that's probably because this is the wrong, see what I'm talking about? I started adding the wrong variables to the wrong checks. If v is less than 0 and z is greater than 1. Yeah. Okay, that should fix the x-axis. And the z-axis is almost working. Oh no, that's probably just solid. That's probably just a solid bit of the next chunk there. Yeah, I think this is working. Fantastic. Now, maybe we should add some directional lighting or something to make this a little bit less A little bit easier to see. So we're going to look at the, what is it called again? Surface Nets Fragment Shader. I'm going to look up light direction and just copy something. Here we go. Not point light. It's not shadows. We don't have normals, so we can't really do lighting. Yeah, I guess we should calculate the normals then first. It's not too hard, right? Shouldn't be hard at all, actually. Okay. So now we're moving from vec3 to some kind of structure. Actually, before I do that, I'm just gonna commit this. So surface nets quad rendering. There we go. I did make a file. I was going to put the surface net stuff in, but I just didn't do that. Maybe I will put it in here in a second. Surface nets vertex, and it's going to be a struct vec3 normal vec3, and I'll leave it at that for now. Okay, now all those times where I said this was going to come back to bite me, this is now coming back to bite me. Okay, so I actually need to... What's the problem here? Pos is not... Oh, this is an array of vertices, so I need to do... this. No? What's wrong with this? Duplicated field in structure literal. Oh. Hang on. Let me just rearrange this. So, we've got an array. Okay. What was the order? 3, 2, 1. Okay. Now, our array is going to have the different positions and the different normals. So, each one needs a position. So, P3. P2. P1. Okay, that makes sense now. Normal equals, and we've got to fill in these. Okay, that's fine. Whoops. Okay. I think we can probably get away with making this a little bit less verbose by just wrapping these and using the positional field assignment. Nope, did I get it wrong? Yeah, I gotta use 2. Okay. So not really much less verbose. I'm probably going to rearrange how this is structured because it's really hard to understand the code here. Just at a glance, I mean, I can understand it because we just wrote it now, but yeah, we need the whoops. All right. Good, good, good. Okay, I'm just gonna make one normal first. and all the other normals will be 0. So let's see. If we got a normal on the negative x axis, then it's going to be -1, 0, 0, right? Okay. Now, all that, I did size of vec3. Where did I do that? Here. This needs to change to surface nets vertex. I did it somewhere else. Was it this one? Yeah. See, I should have just made a type for it and just put a vec3 in it straight away. Or just made it into a vec3, like, you know, you could do this. Just an alias. And then I could have changed it at any time without changing all this other stuff. But I think that's all that I needed to change, so it wasn't too bad. Okay, let's just see if this runs. Okay, it does run. Now, some of the quads should have a normal value, which I can just check in here in render doc. Load last settings, there we go. And we can have a look in this one. So we're actually drawing 3,726. Which is like nothing. Oh, I didn't turn it on in the shader yet. I've never implemented surface nets before. It's pretty interesting. I was going to use marching cubes, but I decided to use something else this time. Okay, so we need that normal, and we also need to turn on the attribute, which is here. It's going to be location 0, no. Location 1 binding 0. Format is vec3, yeah. That's going to be the same, yeah. Whoops, I should have opened this in here. Okay, render doc will give us the info, give us the GOS. There we can see we've got some normals. Excuse me. Okay, some of our normals are assigned. Actually, a lot of them are assigned and they're totally wrong. What the hell? 15.5? That doesn't make any sense. Oh, is it just copying the scalar value from the vertex automatically somehow? Because I didn't set it? Interesting. I don't know if that's what's happening here. This is... yeah, that's wrong. The length of a normal should be 1. So that's totally incorrect. Alright, excellent. So it's good to know that didn't work. Why did that not work though? Vec3 and a vec3. Okay, we're allocating a whole lot of space. We've got one binding, so that's the vertex buffer, and these are the attributes for it. That's correct. 2 vec3s, that's right. What the hell? What if I go to the shader and I just use the... oh, I need to go to the fragment shader and the vertex shader first. So I'm going to pass the normal into the fragment shader. So I'm going to rename this. to actually set that up. Location equals 0, out, vec3, out, normal. There we go. And we'll just copy that to here. This will be an in. And what if we just set this value to, well, the normals? Okay. Right, I see. I must have done a 3D. Wait, what? This looks like a 3D scaled normal or something. That's totally incorrect. So these are all white, which means anything above. Yeah, so this one down the bottom would be black if we could see it. Kind of see the edges of a black square. Yeah, it's kind of, it looks cool, but definitely incorrect. So I thought this would be enough, but no. Okay, okay, I don't like the way this code is written. Can we make this a little bit easier? You know what, it's not a huge deal right now. Let's just grab these and say pos equals, we can just delete that. Normal equals, we'll just delete that as well. So we'll just use positional arguments here. Or positional struct instantiation, whatever it's called. And we'll just do -1, 0, 0 as well. Maybe I should put it on a new line. Okay. So now both triangles on the x-axis should have the same normals. So x is this way. Don't understand where the normals for the other stuff is coming from, since I set them all to 0. Looks like coloring world space position. Yeah, you're right. And it actually is, if we look at the buffer, you can see here, the normal is set to the world space position. So it goes up to 15.5 here, which is really weird. Unless I set up the vertices wrong, but then it looks like the correct geometry. Okay, normal coming in, color going out. I don't have to flatten this, do I? No. It doesn't get multiplied by the vertex position, does it? I don't think so. Alright, let's have a look again. I just want to look at the data again, see if anything changed, although I didn't change anything, so it wouldn't change. So I'm just being crazy, according to common definitions. Let's see. Normals, yeah, same. That's the position. Normals here. Like, I don't get how they have these values, because I set them to -1 on the x-axis and then 0, 0. for here, right? And then I guess I haven't set them for these yet, so let's have a look if we can do that real quick. X, or is it not X? 1. Both the same byte offset. Oh, totally right. Yeah, I think you're right. Yeah, I didn't set the in the pipeline. I didn't set that up properly, I think. Where is it? Yeah. Thank you. Thank you so much. So I'm gonna say there's a, what is it called? Layout? No. Offset of. Offset of, and then we put the type, which is the surface, nets, vertex, and position. Done that before, notice in render doc. Yeah. It's not called position, it's called pos. Okay, I think that will work. Alright. Yes, that's working. Thank you. Good stuff. So we got the X vertices on the positive side, but on the negative side, no. Oh, is negative, I guess negative 1 is going to be black. Yeah, that makes sense. So if the normals are going to be, yeah, they've got to be negative, right? I think you have normal negatives when you do lighting calculations. But then you would get negative colors. The normals usually go from -1 to 1. Okay, apparently that doesn't... Good way to visualize them is to normalize them to between 0 and 1 by doing +1 divided by 2. Yeah, I'll do that. Thanks. Yeah, I could just do it here, I guess. For now. Whoops. Alright, cool, yeah. So we got the blue and the red. Very nice. Okay, now let's fix the other ones, eh? Where were we? Oops. Nope. Nope. Yeah, here. Alright, so y-axis. Now my y-axis is going up, which means negative ones are going down. -1, 0. Okay, and then I'm just gonna do this selection. I'm gonna add here 0, 1, 0. Then down here, z-axis negative. Wait, is that right? Yeah, I mean, I guess that makes sense. Doesn't matter if my y is going up, right? The normals would still be negative. I think. Well, I'll find out. Alright, cool. I've seen this kind of thing many times before. But this is a good... Yeah, this looks correct. That's a bit weird. I thought that was blending. That definitely looks, I mean, not blending, depth testing. That definitely looks depth tested. Oh no, actually. Oh, interesting. Okay, there's a few visual artifacts happening. I can probably turn off the cube pipeline. Oh, apparently not. I think, oh, I've got two selections. I must have commented out something random. Hate when I do that. Okay. Depth test is not working. Did I turn it off? It's not enabled by this, so I'm going to enable it explicitly to true. And actually, this should probably go up above debug drawing. Yeah. Oh, that's not good. What did I mess up here? Okay, what if I turn depth testing off? I don't think that would be the problem. It is. Okay. Let me check the depth test settings. What version of Vulkan / extensions magic am I using? I'm using Vulkan 1.3. The only extensions I have are stuff that SDL3 needs. So, and the debug extensions. That's pretty much it. So SDL3 will need some stuff, I think, to make a surface or whatever. I saw Vulkan 1.4 is out, but I haven't checked it out yet. But I really like this dynamic features. Where is it? Dynamic state, here it is. So there's a few extended features I'm using. Dynamic state, synchronization 2, dynamic rendering. Yeah, it's cool because I did Vulkan 1.0 before and it was kind of a lot, even more code. It's crazy. Nothing new, but things have been moved into the core. Right, okay. What was I doing? Darn it. Depth testing. Depth testing. Okay, so we've got cube depth test. Where is this pipeline? Here it is. Right. Yeah, I didn't turn on color blending. No, we don't need color blending, we need depth testing. You refuse to put effort into Vulkan 1.1, but with 1.3 plus dynamic plus BDA plus bindless plus shade objects, kinda happy. Yeah, I still need to look into bindless. I hear a lot of good things about it. I don't exactly know what it's referring to. Yeah, but it's not that bad actually. the Vulkan version, or at least the stuff that I'm using right now. I think I'm doing a lot of really dumb things because my FPS is really bad, even though I don't have much going on. I think one of the things I'm doing really dumb is device wait idle, and I just kind of spam this a few times around. Oh no, this is at the beginning of the frame. And so I'm not really using proper synchronization. I mean, I'm using a little bit in this function here, which creates a memory barrier. It has some tricks and issues too, but essentially you refer to images, samplers, and depending on if you use BDA, buffers by integer index. Right, okay. Oh, I see. I think I understand what that means. What I really need to look at though, right now, is much lower down. Not that one. This one. Surface nets pipeline. Alright. Depth stencil. Which means you can do something like draw 100k sprites with one draw call and index images by some buffer read. Okay, that sounds pretty good. Yeah. What's wrong with this? I'm going to put the type. You have one global descriptor, essentially. Oh, that's pretty interesting. I definitely want to look into this bindless stuff, hey? Alright. I'm gonna have to go, but I'm gonna call this a success. We have a surface nets implementation. It's using quads right now, but we're gonna make them better next time. But this is cool. I think this has been a very good session. And thank you guys for tuning in. And I'm gonna check out bindless, yeah, for sure. I'll see you later. Take care. Oh, okay. There's like a 30-second delay, but you just said you're doing ray marching 2D light and soon Radiance Cascades. Yeah, Radiance Cascades looks really cool. I really want to try it out. I'm kind of trying to level up my graphics programming to get up to that point. So yeah. Do you have any videos or anything about it? Oh, you might already be gone. The 30-second delay is really annoying. Oh yeah, I'm in that Discord server. It's the Radiance Cascades one, right? I can see you, I think. Yeah, most people in there are doing 2D radiance cascades. I haven't seen 3D. I've only seen one 3D implementation or two on Shader Toy, but it seems pretty rare. I guess it's probably much harder and hard to get performing well. That's my guess. And anyway, yeah, sure. I'll send you a message. All right, I gotta go. Have a good day. Take care.